And we're back, everybody. So we continue with the next session of the day, and then it's my pleasure to welcome Niels. He's both a security researcher, but also has a background in .NET development. So these are the perfect ingredients, let's say, to discuss how secure is our .NET application. Right, Niels?
Yeah, that's definitely the topic I'm going to cover, and it's going to be about, let's say, the whole span of what our software, let's say, like the way that we deal with our software has become more complex, so there's a lot more things we need to be aware of, and that's exactly what I'm going to talk about. Give some nice examples about stuff that we've seen, and what, of course, we can do about those problems. That will be the end of this presentation then. So.
Sounds great. I always like this type of presentations where you can, let's say, it's sort of a problem and a solution, especially in the realm of security. So then, yeah, you have the floor, and then we'll regroup at the end to discuss more and then maybe tackle some questions from the audience.
Okay, sounds good. So thanks. Right. For supply chain attacks, how secure is your .NET application? That's exactly that's the title of today's session. And I'm really happy to be here at CodeCamp virtually, right? I think every speaker before me probably has mentioned that it's unfortunate that we need to do it like this, but hey, as long as everybody's healthy and safe, then this is a better option. So I would like to welcome you to my home office in the Netherlands, where I'm working for Veracode. Brief introduction of who I am, because that's always polite to do. So I work as a security researcher for Veracode, but I have a background in .NET development, and I started out developing with the first bits of .NET, so 1011. I think it was 2001, 2002. And I always kept an eye on application security, because that was like my field of interest, and that was the thing that I also enjoyed. In 2014, I got the ability to fully move to the security space, where I also did some pen testing, ethical hacking, and security consultancy. And in 2015, I joined Veracode, where I'm right now on the team that's responsible for researching all the stuff we need to do for our static analysis, right? And for me, it's mostly focused on all the .NET applications, all the SDKs that are around, and I'm just like programming, let's say, the hell out of it, and make sure that we get the things that we want to like share with our customers. That's the thing. So I'm combining a lot of good things into one role. It's really cool. If you want to talk more about Veracode, come see me afterwards, because today the topic will be the rise of software supply chain attacks. And it's going to be a lot of content. It's going to be dense because we have 45 minutes. So I'm going to go through and I'm going to quickly briefly share the agenda of the things that I want to talk to you about. So first, because it's fun, I first want to touch some hacker history and look at the way how hacks have evolved over time, how it started out, and how we also need to correlate that to the way that we develop our software and what else has introduced. Then we're going to create a definition of the software supply chain. That will be the main subject of this session. So we're going to define, like, what do I see as the supply chain for this talk. It has to do, of course, with development of a .NET application and relation to building, releasing, and deploying. And then I think the key thing would be, like, how can we take the bright countermeasures for all the security things that I'm going to talk about. And at the end, as Dan mentioned, we're going to open up for questions and conclusion and Q&A. The slides are in a repo that I share at the end of this presentation. It's my GitHub repo. It also has the code for the demo I'm going to show you when we're talking about securing. If I'm referring to links, if I'm referring to other stories, then the links will be in the notes. You can see two versions of the slides. So if you're interested in getting the links to stuff, just look into that. So fun stuff. Let's first start out with hacking history. I think if you look up hacking in general, the first thing you will probably run into is something which is called phreaking or phone hacking, which happened in the late 50s and 60s. The picture you see over here is something that they call a blue box, which is a device that allows you to create phone conversations, to dial a number and to connect to something, right? This was usually used to do some phone phreaking, call with people, maybe do some social engineering. And this is, I think, the basis of all the things you see. And this like slided throughout the 80s and the 90s. And there's a lot of good, cool stories about hackers that use this and that have done a lot of these things. So what happened in the 90s, right? I think in the 90s, the biggest thing would be, like, we have computers. Computers came to, let's say, universities, organizations start using it. And also something came around, which is, of course, the internet, which resulted in machines getting connected, right? So machines were able to be accessible throughout the internet. And in 1995, a guy called Wietse Venema, a Dutch guy, in combination of, I believe it's a US guy called Dan Farmer, released a tool called Satan, which is the security administration tool for analyzing networks, which, as far as I'm aware, is the first vulnerability scanner and exploitation tool that you could use. You can scan a network, you can connect to it, you can even exploit services which are like connected. And keep in mind, like most of those machines that got connected to the internet had no intention to become connected, which of course caused a lot of problems. The screenshot you see below is a tool called Nmap or Network Mapper, which was released in 1997. And that's a port scanner that will check TCP connections, UDP connections, depending on how you configure it. But you can analyze and see what type of services are exposed throughout that specific public IP address, or internal, depending on what your scope is. But that allows you to determine the attack surface and to determine how you could attack this. If we then move on, like what would be the next thing that happened? Because the computers became more connected, hackers also focused more on problems that lie in the software, so that lie in the implementations that are being made, that are like used as one of the services that is exposed on that machine. So in edition 49 of November 1996, a hacker by the name of LF1 wrote an article on buffer overflows, and as far as I'm aware, this is the first article that was published around that, which of course people have done C++ programming, and if you declare a buffer and if you put too much data in it, then it will cause problems, resulting in a lot of, let's say, possible code execution and a lot of security implications, right? Frack is still around, you can still find all these issues, and in addition, later on, which was published in 1998, a hacker called Rainforest Puppy talked about SQL injection, and that's probably something you've heard before. And he showed some things related to SQL Server, which of course what happens is that if you take external data or end user data and use it directly into a SQL statement that's a string, and you concatenate it in, that's dynamic SQL, then you can influence the logic of a query and even do a lot more, right? That's of course what happens with SQL injection. So we moved from network infrastructure to more focusing on the software that was running. And what we then saw was, like in the early 2000s, is that, that there was a lot of stuff happening with worms. And I think one, I was at least like, that I was not involved with, but that was the first time I can recall was, of course, both Code Red and SQL Slammer. The screenshot below you see here is one that's the GET request that the IIS server got, which was vulnerable to Code Red, which eventually resulted in code execution. I believe this was a buffer overflow that was inside, and this was something that was done on a large scale. It became a worm, it became automated. So what it did is that it hacked the machine, but it also infected the machine to infect other machines, right? And that's the thing that we see, of course, nowadays a lot more, where that compute then gets used against to do more stuff, which of course has a lot more impact. Of course, every software vendor had these problems, right? In 2002, Bill Gates sent out a trustworthy computing email to all its employees explaining that it is important that security needs to be done by default and by design. From the beginning, you start writing software, you need to consider the security risks and need to consider taking the right design decisions, right? I think that's the thing that he wants to achieve with that. So that's the evolution of hacking, moving into software. And then if we look at the way that we started out like development and how I started out my own development with .NET is I wrote monolithic applications. So a single installer for, let's say, one customer that was like an MSI that I would give to the IT department of that customer, say like, hey, install this on your server. Then you're good to go. You've got the newer version of your tool you're using internally to maybe smoothen out some business processes, right? That's the thing. That's the monolith. So over the years, we like the way that we write software has like changed. And it was like more like an evolution towards microservices or service orientation, where we take the app you see in point one into more like a services type of, like dissected into smaller services, which allow you to focus on smaller things and also release smaller bits and pieces all at once, and also allow you to scale a bit better, right? The point two is one, let's say if you've got like the app, that's the monolith and you want to scale it, you need to have multiple instances running of all of it, right? And if we then move to the third dot of this picture, then you see it's a microservices approach, which is like a smaller dots that will be used. And in the fourth, you probably see something that it's a cluster of different services that run on, let's say, a cloud native infrastructure even, That's more small, more granular. But so with that change of the way that we develop our software by saying like installing an MSI and then moving to continuous deployment, because that's what we're doing right now, that also changed the way that we write our software. And that also introduced a lot more supply chain, let's say, that introduced a more complex supply chain and also a lot of more issues. And that's the thing we're going to address today. So I usually take an analogy of the automotive industry to tell a bit more about what the supply chain is and how you could, let's say, look at it from a more abstract point of view. So if a car gets manufactured, then at some point in the plant, there is like a first stop where the chassis starts and there's nothing else. And then across the factory, it will go through steps, and each step it will have parts added to it, right? At some point, the engine will be put in. At some point, you will get the tires put on because it's almost at the end. And each of these steps make up the supply chain of that car from beginning to end. So from the beginning, it's just a piece of metal. At the end, it will be that factory, like it will be that rollout of that car, of that factory plant, because it's going to be delivered to the customers. If we take an average car brand, German car brand, each car probably has 10,000 parts, which originate from 2,600 different suppliers that's been put on, right? So imagine that. So a lot of small bits and pieces coming from a lot of external sources being put into that single car, right? Which makes the supply chain complex. And that's a good analogy. If we then look at a software supply chain, we can do similar things, right? So this is the abstract view of the .NET supply chain I'm going to talk about today. It's of course hypothetical, right? It's not like this is the thing you need to do, but it will just give you the illustration of the areas I want to talk about. And in this case, you of course see there's a developer that starts writing code. First step of the supply chain. It then puts his code into a repo, a Git repo, or in this case, Azure repos. I've taken the Azure ecosystem for this example, but you can just replace it with GitHub or with the GitLab stuff you're using, or Atlassian, it doesn't matter. These are all the same, like it's more like focused on the different components with their responsibilities. Right, so a developer probably gets packages, external resources, third-party libraries from external sources like NuGet, npm, or Docker. And then eventually, it probably triggers a build on Azure pipelines in this case that will grab source code, that will grab the dependencies, that will build, maybe even grab Docker images and create Dockers out of it. It will run additional test plans in order to make sure that QA also is happy before releasing, right? And at the end, it might be that a Docker image will be put into a container registry and then will run on top of Azure Kubernetes service, right? So hypothetically speaking, this is the software supply chain, and these are the different components I want to talk to you about and talk about the security things and the security problems we're facing. And in this case, let's first focus on developer and also focus on the development machine, right? So if you start out at a company and you get like a laptop or a different machine, like a provision for you from the IT department, then if it's a new machine, there probably is something on that device, which is like a secure boot or a trusted platform module that will give you some guarantee that the machine has booted with firmware that has been signed and that has been authorized by the vendor itself, right? So in my case, it's a MacBook. It has that module. It will start out, and I will have some guarantee that that's the laptop, and that's exactly that it's working like it has intended to be working. Of course, on top of that, your machine probably will be maintained. Hopefully, updates will be installed, and also, if it's a development machine, I'm assuming that there's also some hardening done. What I mean by that is that turn off stuff that you don't need, because even on a development machine, you want to just like keep the minimal stuff and also keep the attack surface minimal. And that's the thing we're going to see later on, so don't worry about that. Even if there is data on that machine, it makes sense to encrypt that disk, right? If there is an intellectual property of the company that you work for, or maybe customer data, that's the thing you want to safeguard. And I think that's the minimal thing you can do encryption. But there's the question we then, like, if we assume that that's all okay and put a green mark behind it, can we then answer the following question? Can we trust the hardware that's inside of it? If we look at the video that was published of a talk that was done by Andrew Wang, also known as Bunny, at Black Hat Israel in 2019, we cannot trust it, to be honest, right? And this is probably getting a bit of, let's say, paranoia inside. He talks about how hardware and supply chains that create hardware can be hacked in different ways, and also how it inherently is tied to the fact that chips need to be manufactured in a specific way, and it's hard to distinguish. So technically speaking, hardware can be hacked. Can we trust our machine? That's the question that I'm asking you right now. If you're interested in knowing more about this, then I would encourage you to watch this video. And there's definitely some possibilities. So, but let's now just say we're safe and we can assume that we have firmware on our machine that we can trust, that we can trust the hardware, that we can have all the patches installed that we need. So from that perspective, our development machine is good. We also need tools to do our software. And as I already mentioned, I'm working on a MacBook. So if you want to install tools that help out development, let's say like Python, or if you're like running OpenSSL or OpenVPN, you need to go to the internet and install it. And unfortunately, Mac has got no one-stop shop to go to say like, hey, I want to have this tool installed. So somebody decided to create a tool called Homebrew, which is helping you out installing things. And if you then go to the page and if you then get asked like install Homebrew, then you will see that bash command you see on the second line of this slide, which means that it will fetch a file and install script from GitHub, and then it will execute it against bash on your machine. And the question you of course need to ask yourself, like, hey, do you want this? Because you put a lot of trust in the fact that you get that file from that location. Are you sure that that's the right file? Of course, you can look into its content, but trust me, looking at that install, there's a lot of complexity that is hard to understand. So it's just a leap of faith. Grab that file and install it on your machine and hope for the best, right? That's technically what's happening. And people always come back to me like, hey, if you're on a Mac, that's the thing you need to deal with. But keep in mind that if you do the stuff with Chocolately on Windows, it's exactly the same. And if you go to their website, they even have got like a disclaimer for the exact problem I just mentioned to you. Make sure that you download the script to install it, like the PowerShell script they're referring to. Make sure that you have some sense of what's happening inside, right? They say like you can trust us, right? But it's always good to verify and make sure that there's nothing wrong with this. So looking at that that piece, this all has like the different things I just touched have all influence on your development machine, and that development machine will then be used to develop code. And code, of course, will be written inside an IDE. And we're even at the stage where malware targets our development environments, right? So in May of this year, the GitHub Security Lab team published something called the Octopus scanner malware, which turned out to be a piece of malware that was targeting in the NetBeans IDE, and that would infect each jar that was being built with that IDE and put, I think it was a malware dropper inside of each of the jars that it was produced, right? So even if all the hardware stuff is in place and we can mark it off, if your IDE is compromised in this way, then the software that you would produce might be still containing problem security issues, right? And that's that step of the chain, which is the problem, of course. So that happens to at least NetBeans IDE. This is a bit weird story because I'm assuming this is definitely a targeted attack, because there has been put a lot of effort in this if you read through the article on what it's doing. And I think it's a really small group you can catch with this. If a hacker's got bad intentions, then personally I would target a bigger group to gain more, right? That's the thing. And that's the question. That's not completely clear behind, like, who's behind this and who has done this. So myself, I do a lot of stuff on VS Code, and I love VS Code. But VS Code is written on top of Electron. And the thing you see over here is a website which you can go to that allows you to get a dependency graph of, in this case, the Electron packages that the VS Code is using, right? So this is a dependency graph with all its transitive dependencies, right? So you can see a package that depends on another package that's underneath, right? It will give you the whole tree of dependencies. All these different packages, in this case 82 dependencies, are being developed or being maintained by 110 people. So 110 people touch these dependencies that end up in VS Code, right? And don't get me wrong, I think this is the power of like community-driven software development. And VS Code, I love VS Code and all the things you can do with it, because you can literally take every programming languages, get the extension running, and you can develop it and that's nice. But there's a flip side to it, because there's 110 people that will work on the packages that end up in Electron, right? That ends up in VS Code, but it also ends up in Slack. Slack is using Electron underneath the hood also. And even to put it more, there's 110 maintainers, but there's even more, keep in mind, there's even more people contributing to that code. It's not that only 110 maintainers, there's a lot of more people that will touch that. Electron itself has got its security issues, right? In 2018, there was a way of how the node integration could be bypassed and you can execute code against it, which affected, of course, all the things that run on it, right? As you can see in this article, it relates Slack, VS Code, Signal, GitHub Desktop. They all rely on this. So that's the thing. And on top of that, if we run VS Code, we need to have extensions. And this is something that was published in August of this year. That's the CVE, as I highlighted in this article, which is the public identifier for a security vulnerability that has been published. There was a JSON remote code execution vulnerability in the way that VS Code parses packages.json files, which allows people to, if you would, let's say, get a repo, clone it, and the package is JSON, and then I think there was something related to hover over. There is some rendering action happening, and that allowed somebody to inject code, which of course that's a problem, right? And that needs to be fixed, and luckily it will be fixed. Secondly, this is 12 days ago. I just grabbed this issue this morning. Still, there remains a problem with this, right? So, not to scare you, but I think it's important to be like always aware of the fact that if you use an IDE, and if it's being developed and there's a lot of chain, that IDE itself also has its own supply chain of all the dependencies you saw earlier and all the people that are involved. And all it needs to be one thing wrong in that supply chain, which will result in your supply chain being compromised. So let's move on. Let's move to dealing with source code. So let's assume for now our development machine is safe between codes. Let's dig into doing stuff with code and doing stuff with dependencies. In order for us to get dependencies, we need to communicate to package managers like npm or NuGet. And a lot of our internet communications rely on TLS or HTTPS, right? Which is a root authority trust system that has like certificates that have a tree of trust behind it. That ecosystem has got its own problems, which we can probably talk about a lot longer. If you're interested in know what problems there are, I would encourage you to go to the SSL Lab side of Qualys and look into the threat model they created around it. But the most important thing is that there are some problems with, let's say, TLS 1.0 and 1.1. And luckily for NuGet, they don't allow you to use those TLS versions anymore. And that, of course, has to do with the Heartbleed and the Poodle attacks that were inside of browsers and allow somebody to eavesdrop the network traffic. So that's a problem, right? The communication at TLS, I think in fundament, the system is broken and we cannot trust it. Same problem lies in the fact that the domain name service we need to do. So if you want to go to NuGet.org, we need to translate that to an IP address in order to get to that address on the internet. That resolving can be spoofed, right? And that can be a problem. There are solutions to that. One of them is called DNSSEC that will do some cryptographically signing of DNS records, right? I'm not going to go into details, but unfortunately, both NuGet and GitHub don't support that. And I think that's a missed opportunity because that can be an additional layer of defense into that thing, because at some point a development machine will communicate with those services, right? And you want to make sure that you can trust the channel, as I already mentioned before. So this is related to communications and what can possibly go wrong. If we then move to the fact that we need to connect to a repo, let's say Azure repos or GitHub, then we need to have credentials to connect to that repo, right? And what can happen with credentials? Credentials get stolen, and in this case, a canonical GitHub account, those credentials were stolen, I believe. It was just ordinary credential theft, would allow somebody with those credentials to access the Ubuntu source code. As the subtitle in this article implicates, is that The Ubuntu source seems to be safe. However, Canonical is investigating. This is probably, at this point, they had no idea what was happening. I think at the end, somebody just created some additional projects. That's it. So there was no compromise done at all. But you can probably see the impact of this, right? Credentials stolen. And this was Canonical. And do more companies suffer from it? Yes, they do. So in, I think it was June, this was May of 2020, also this year, a GitHub account got hacked, and this is also, I believe, just credential theft, and somebody stole 500 gigabytes of data, which also included a lot of the private repos of Microsoft. And a hacker group called the Shiny Hunters tried to sell it on the black market. So this is also like just the fact that you need to authorize with that repo in order to get your source files, push commit changes to it. That's of course a problem, right? And what do we need to do with credentials? I think if there is one thing you need to take out of this presentation is that I would say use multi-factor authentication for each and every account that you're using, and also for your source repositories or like the services that you're using. In this case, GitHub, like you see the authenticator, Microsoft Authenticator in this page that will create that OTP code that will rotate. And you will have your username and password and this code in order to get into GitHub, which will, if a user name and password is stolen, an attacker doesn't have this OTP code, and that will be the additional factor in this whole authentication dance. And therefore, you have safeguarded the account. So, as I said, if I want you to take one thing out of this presentation, check your accounts, make sure you can put it on. Every major service has it, so just use it. On top of that, if you're working with a Git-based system, there's an additional thing you can do also to secure your source, or at least have some more authenticity checks inside that, which is called Git Commit Signing. And what happens with that is that you also have a public-private key pair. And with that private key pair, you will also sign the commits that you push to the Git repo in this case. And you will also put in a public key inside Git that will allow them to show that this is verified. Meaning that this is the additional factor. So even if your password, username, and even the OTP gets stolen, then the changes that are being made can still be distinguished, like they'll still be distinctable because somebody won't be verified because he lacks that additional factor of that private key that you will use to sign your Git commits, right? So this is also a best practice I would encourage you to dig into to see if you are able to deal with that. So moving on, source code, let's move to the fact that we use third-party libraries. And this is an example I've used with a lot of my presentations, which is related to the event stream NPM package that was hacked in November 2018. And the biggest problem with this thing is that aside from what happened is that this package is a transitive dependency of 2,000 other packages. And it has an average download of 2 million a week. So if you're able to inject yourself into this package, then you could probably guess the audience that you can hit with this, right? And that, of course, an attacker wants to gain a lot, I would assume. In this case, I believe the attacker just targeted a specific Bitcoin wallet to steal the cryptocurrencies out of it. Not a good job, but and also the funny story behind this is that the guy that was involved with this jumped on the project. The project was pretty stale. There was not much of development done. He eventually got maintainer access, and he was able to contribute, which everybody was happy about. And then at some point, he decided to become malicious and add the additional stuff to this package, right? So it's more like a social engineering thing, and this is an example similar to what we have seen with Electron and the npm package tree. Like if somebody, or even like with a NuGet package that gets developed by a group of people, there only needs to be one with bad intentions that might result in this. So we talked about development. We talked about grabbing source, putting source into source repositories, dependencies, and the problems that we're facing with that area. Now let's move on to building our system, and let's move to the fact that we are like doing that continuously, right? So we can ask ourselves similar problems as we have done with the development machine. Like, what about the hardware? Can we trust it? Similar with if you're running, let's say, hosted agents or the agents of a cloud vendor, then how can you trust them that they do the right thing? What about the TLS issues I just covered, right? And it's also not unseen that the Docker images get compromised. And I think that even amazed me more is that if you look into Docker and you can do different ways of authentication with that. But if you're doing username, password, they do have two-factor authentication, but it's still in beta. It's not like publicly available. You need to turn it on. So I was a bit amazed by that when I was doing research for this presentation. But compromises of Docker images happen, right? And it's something to be aware of. Also, the build server itself can be compromised, right? So keep in mind, like we're talking about the chain and the different areas where software gets tested, gets built, gets written, and also gets built. But what if the machine that's responsible for building gets compromised? Or one of the components that is being used in order to build that software is compromised? This is something that happened in July of this year, and that was related to Twilio's Taskrabbit.js SDK, which turned out to be compromised because somebody was able to inject files into the output of the SDK. I think it was like quickly noticed, but at some point the build process that was responsible for this SDK, right? So the supply chain that was building this SDK got a file from an S3 bucket which wasn't properly secured, and somebody put in a different file. And then that was incorporated inside of that SDK version. So with this compromise of this SDK, like every software supply chain of, let's say, the company that you work for, or other companies that like use Twilio services, technically are compromised because this SDK was compromised. And in 2019, around August in 2019, there was also a story being published at the AppSec Village of DEF CON, which is a hacker conference in Vegas, which was related to Webmin. And Webmin had one of his build servers, which was like a physical machine that was reused to build the Webmin package, compromised. And I believe that it was even compromised for more than a year. So there was like multiple versions that was like being built with the server, and what the attacker has done, he put in additional modules and additional malware into the output of the Webmin artifacts that were being published. So keep in mind, even if you do source code, signing, all the things we talked about before, if that build server is compromised, then the package that will be produced is compromised and your whole supply chain is compromised, right? So they eventually fixed it, and they will luckily to have a span like these versions were infected. So it's pretty, let's say, it's a pretty lot of impact, a lot of like ways on how to hack a software supply chain, as we have seen in the previous slides. The different components can be hacked on a different thing. So let's move on, and with the last 50 minutes of this presentation, let's move on to how we can fix this problem. And one thing we first need to do is builds need to be reproducible and deterministic. And what I mean by that is, how can you have a guarantee that the source code that was in the source repo that was being used to build a product or build a library is also the code that has been put into that package that you use, right? So let's say if I look at newtonsoft.json, if I go to the GitHub repo that's tied to it, how do I know for sure that if I take a branch and a version or a tag that's being used to build that's the source code that has been put into the package that I'm using in my application? The only thing you can like guarantee is that if the build is reproducible, meaning that if the same source code produces the same output. I'm not going to spend too much time because there's a lot of content in this slide. Luckily, with .NET Core right now, builds are deterministic by default, but there are inputs that they've defined, and that all depends on, of course, the stuff you've installed, like so which SDKs you're using. There are some things still inside, which might be the like referring to files, which you need to be aware of. But there are some good guidance, and in this slide there are a couple of links to articles that explain to you how .NET Core is deterministic. So how can you grab source code, build something, and then validate it against the artifact and say like, hey, this is the exact same source code that was used. That will give you that guarantee. So we're going to step back. We're going to look into the automotive industry again, because they've came up with a solution that will fix some of the problems that I've talked about before. So in this picture, I think it's something that it's a German and also a Dutch car magazine that will publish a completely disassemble of a car after it has driven 100,000 kilometers and see what the wear and tear of all the different parts were. So you probably have been in a situation where you got a message from your dealer or from the car brand that you have a recall on your car saying like, hey, you need to go back to our dealership because this part needs to be replaced because we have run into a problem and we know that there's a problem with that specific part. So for some reason, the automotive industry is really good to keep track of all the things that are put inside the car, right? And let's just quickly talk through a hypothetical supply chain in case of disc brakes that are being used on cars, right? So in order to produce disc brakes, we need to have steel. And in this example, the Tata Steel Factory, which is one based over here in the Netherlands, has used iron ore that came from Sweden that will then produce steel that they, of course, will test, right, in order to make sure that it meets all the quality standards and that they will identify with a number and a badge. Then that steel might have been used by the Bosch factory, which will produce the disc brakes out of it. They will take that steel branch, like the steel badge, they identify that. They will then do their own testing, produce the disc brakes, make sure that it fits their quality assurance. Then they will put the serial numbers on it, or at least like make sure that they are identifiable, and then they will distribute it across the channels of the cars that will be using this disc brakes, or the manufacturers, in this case Ford, Volkswagen, and Kia, for example. Then if that disc brake ends up at the car manufacturing plant, then that will be put on a car. And a car will consist of a lot of more parts, right? That will have the discs on it, that will be an exhaust on it, there will be tires on it, and that car will then be identified with a vehicle identification number. So all the things come together, and each of the steps in this supply chain has got its own way of identifying the things. So let's say later on, turned out that the steel badge that was used had some faults in it that will allow it to break after X amount of time, right? Then Tata can then talk to the Bosch saying like, hey, this badge you've used has got some issues. Then Bosch can get back to Ford saying like, hey, the disc brakes you used from this serial numbers have got some issues that need to be replaced, right? That's something that's called a bill of material, right? So knowing exactly what's inside, where it originates from. And from software, we need to do exactly similar things. And that's something that's called a software bill of material, or SBOM, which is a thing that's being written right now. It's being worked on by Google, by Microsoft, by a lot of big companies because they really see the needs for having this. But it should be an industry standard that allows you to describe software, right? So who created it? What's the product? Can we have some integrity checks on have it's been altered or not? What materials were used, like what's the source code that was used, right? So there's a lot of things you can capture in that ledger that will have all that information in. One good example of a lightweight SBOM would be something called Cyclone DX, which will allow you to produce dependency graphs for different technology stacks. So recall that VS Code thing I showed you. There is a tool that allows you to produce files, JSON, XML based, I believe, that will have the full transitive tree of all dependencies that your apps rely on. And that you can then use to check like, hey, if there is a known vulnerability being published for your like product or like a library that you're using, you can check all the SBOMs of your application, look for that specific thing if it's being used, and then take action on that, right? There's also the National Telecommunications and Information Administration in the US, which have put in a lot of effort in getting the SBOM more consolidated and more guided and usable throughout all the industries. Because as I said, it's still an ongoing process. There are different initiatives. If you want to search for some good like documents on SBOM in general, then I would encourage you to go to that link that I put in this slide. So this is all like some process and some policy things, but luckily there's also tools being written already right now that will allow us to do better things with inside our software supply chain. And we're going to focus on a bit on InTodo, and I'm going to give you a demo of InTodo and how it can help you out. So InTodo has the goal of a framework to secure the integrity of the software supply chains, right? So if we look at the picture of source to building, we want to make sure that we have done all the countermeasures on each of the different problem areas that I just talked about. But how do you have the guarantee that source that it was being put in by the developer is also the source that's being used to build that product on that build agent before it gets deployed? That's the whole supply chain, and InTodo allows you to secure that in a better way. And that's the thing I'm going to show you a demo of. So First, let me just briefly touch some terminology on this. So don't be afraid if you don't get it all at once. I'm just going to talk you through a bit in order to have some picture of what I'm going to do. So within the terminology of InTodo, we have got something called functionaries, which are people that are part of the supply chain. So, and that will be identified by a public key pair, public-private key pair, right? So it's public-private key pair based, and there's signing happening, which is the private key that will be held by that functionary close, right? It won't be shared, and the public key allows you to validate that thing that's been signed, and that's the whole check that you're doing. So there are three functionaries in this demo scenario. There's myself as the project owner, Niels. There's MA, who is the developer of the project, and there's Noud, who's responsible for the packaging and the packaging of the app. So the project owner, myself, I will define a supply chain layout that describes what happens, by who, and what are the produced materials, and what the byproducts are, right? So that's I think that the biggest power of this concept lies in the fact that you can have produced materials of one step and then use that as input of the other step, which you will see later on. You can also do byproducts, test results, maybe static analysis result files. You can put those in and also let them be part of the whole chain and validate against it. Each step will then be executed and it will produce a linked metadata step. And materials are input, as I said, products are output, and materials can be used later on. And at the end, you can validate, and you can validate the data that's been produced. So let me switch to VS Code. Hold on a second. I'm going to go one back. Can I quickly switch to this? Not sure. There it is. It's a matter of focus. So this is also in my GitHub repo, right? And you can just briefly look into it once we're done. Let me just quickly show you. So I'm the product owner, and what I'm first going to do is I'm going to create the layout. And in this case, if we look at the layout itself, let me just quickly produce it. It will produce a layout file, and in this layout file there's some cryptography happening, but you can also see there are materials that I'm expecting, there are products that are being output. So this is the definition of the supply chain and all the steps that I want to validate against. It also contains which functionary is allowed to do which step, right? So the developer can only do stuff and the packager can only package up and deploy it. That's the thing. We're going to see some demos of it. So I'm going to share the layout with the final product because we're going to validate the final product at the end. And I'm going to put in my public key because I signed this layout and you can use the public key to validate it. So let's move to the developer right now. And let's do a create. So I created scripts that will do some things. Let me quickly open it up for you because I can type it, but then you're just gonna see me do mistyping and all the other things. So what it does, it starts an InTodo process and it will say, okay, create a new console app. That's it, what it's doing. But it will do a step and it will also use the key, in this case, of a May, to sign this step. And it will also identify a product, which in this case is a single source file, and it will be signed. So if we then look into this, this is the proof that this step has been taking place and that it's been done by the person who is allowed to do it. So now it's time for the packaging to happen. So let's say now it grabs the source code from the Git repo and works on it. Right now I'm just doing a copy, but let's say he's going to package the app. He's going to first publish it, which will do a .NET publish, right? That will create the package itself. Nothing fancy happening with it. So let me open up, right? So it's just doing a .NET publish with similar things like, hey, these are the materials. I'm expecting this source file to come in, and the products are inside the published folder. And then it's going to do a package step, which that's not what I want to do. Package. As I said, typing is hard, and that will do exactly the same. That will produce a package link and also produce the tar.g set, which has the application inside of it. So let's move on. Let's make sure that we have all the artifacts in a single place, right? So this will have our end product, which in this case is a GSAP with the application in it. It has my public key, it has the layout, and it has all the steps of the intermediary actions that have been taken. So if I now go to find a product, I can say InTodo verify. I can say verify this against this layout with the keys that belong to me, and also put in as verbose. You say like, okay, this is it, but it has verified all the steps, and it has done it based on the layout that we created. And in this case, it has said like, hey, it has passed all verification. Okay, so far so good. What now if there is a hack done? And I'm just going to quickly run a script that runs some cleaning up. So let's say at some point now decides to become a developer and decides to do a change to the source code. So he's changed the program.cs file. If he then starts to say publish, I'm not in the node folder, I think, functionary nodes, no. If I then say publish again, I need to keep an eye on the time. Let me quickly wrap this one up and then we can move on. And then the publish, you will see that we have created the other files, right? So there's the publish and then the package. Need to do all the step package. Then we have the same artifacts. Let me do the action, right? But in this case, the files have been altered, right? The source files have been altered underneath. So if we then go to final product and do the InTodo verify again, we will see that there's a problem, right? And it has to do with the program.cs file that didn't match. So in this case, the files that were supplied, like somewhere in the chain, there was a compromise and there was a change done. So InTodo has got a lot of potential. It's still academia, right? And it has been publicly, I think, for a couple of years. If you're interested in the story of a company that uses it heavily, you should look into a Datadog blog post that will tell you how they use InTodo to verify their agent deployments and do similar supply chain checks. If you're doing Google Compute and if you're using their platform, then Graphius and Cretus are two tools that allow you to incorporate InTodo and InTodo artifacts and allow you to do conditional checks on artifacts that you've published before you go to production. Binary authorization allows you to go do a no-go or go on a development, right? So you can check the supply chain of a piece of software and see how it's built and then do that for Google. Azure Pipeline's artifact policy has got similar aspects to it. It only right now allows you to check to, let's say, check Docker images and see how they're configured. But I think this would be the right point to also include stuff like checks for like InTodo in order to validate the supply chain of a product before you deploy, right? That's the powerful thing. So quickly wrapping up for the conclusion, then we can open up for questions. So I think it's important to be aware of your own and others implicitly auto-used supply chains of your software. I think you need to be aware of what you are like consuming and pulling into your projects, right? Use multi-factor authentication on all your accounts. Of course, I cannot like do a security talk without saying integrate security into your development lifecycle. Do it from the start. And I would definitely encourage you to learn more about software bill of materials by looking into the links I've shared. So all the slides that I like published are like inside of this GitHub repo. And as I said, the links are in the notes. And the demo you can also find with all the scripts on the same repo. And with that said, then I think we can open up for questions. And I haven't looked at the chat at all, so I'm curious if there are any questions, because it was a lot. I'm sorry about that.
Hey, Niels. Yeah, very educational, but scary at the same time. Yeah, learning about all the things that can happen, and also examples that they did happen at some point.
Yeah.
That's very good. Yeah, I was thinking for developers. So there are things that there are an issue at some point, like SQL injection or something. But then you see that frameworks incorporated ways of preventing that, and then bringing that to the developer toolkits. I think then you have security teams in your project. So then you were talking about integrating security as early as possible. What should be the developer attitude in this case? What's a, let's say, proactive approach?
Yeah, so I think it's important to be aware of security problems. That will be the first step, right? And you can probably do some trainings on vulnerabilities and see like what type of implications, let's say, dynamic SQL has for your application, right? Secondly, I think it's important for security vendors to integrate more into the development tool space, because that will be the most cost-efficient spot where it can be fixed, right? I think. With the tools, like traditionally, most of the security checks were done at some point at the end before the tool hits production, right? And our static analysis usually is run also in that stage, but you can run more tools more frequently and also more upfront, right? So for us, we have like a pipeline thing, which is pretty quick, that you can literally, every developer should be able to run at the point before they're checking their source code. And I think that should be the key, at least, to get more mature in your software development. And the other end, I think it's also important to be aware of the risks that you're facing with your app. Usually get the question like, hey, what do I need to do as a developer? I think the first thing you would always need to do is draw something about the app, like create a threat model and identify the problems that do matter for your app, right? If there's customer data involved, like how we're going to communicate to that database, how we're going to do like basic, like if there's a way to query databases, make sure that it's consistent across the line, right? That kind of things. I think that's the thing that can add the most value for a developer, and to do it more upfront, right? And hopefully the tools will evolve even more. I know that we're focusing on it, that the developer has got more at its fingertips, because that's the spot where the code needs to be fixed. And that will also be the cheapest to do, right?
Exactly.
Yeah.
Hi, Niels.
Hi.
I'm Florian. I was just injected here.
Okay.
It's a security breach, but
yeah, I'm sure of that.
So one more question, probably the last question for your session. What's the state of the industry? Because you're exposed to lots of companies and
so
what's
what
happening
we do,
in the industry?
We publish a report each year, which is called the State of Software Security, that will show verticals of how each industry is dealing with security problems. I think overall there has been some improvement, but the basic things are still around. SQL injection, I think, is 20 plus years, right? As a concept, as we have seen, and we still need to deal with that. I think, like, from network connectivity and having machines connected to the internet, there's definitely a lot of things improved. But in the application layer 7, right, that's still the biggest problem. And even with our software becoming more complex, as I talked about, that will even make it more difficult. And not to be fully negative, I think the industry is definitely maturing. The thing that I like most about .NET Core, for example, is the way that the SDK will force you to take the secure default, right? If you want to do a bad thing, then there's an API call which explicitly almost states that this is a dangerous thing to do. And I'm really happy with that. As long as the defaults for the developer are in let's say, the good choice to make, that will help out. And I've seen that .NET Core is the right example for it. I think there's a really good job done in that space. But yeah, from the other end, like, software is eating the world, right? Every business will run on software, and that will be something that we're just stuck with. And yeah, so not to be too negative, it will be around. We need to focus on doing the right thing, but that's similar. Like, there's quality aspects of software that we still also need to be aware of, right? It's not only security things, scaling, even doing cloud native at large scale. It's nice to have a lot of compute, but if you make the wrong design decision, it can also be a costly thing to do, right? But yeah, that's the thing. I think we're getting better, but there's definitely work left to do for us. And that's the reason why I like to talk about this to developers and share my knowledge in that space, right?
Yeah, indeed. So I also think, yeah, first of all, awareness, it's the primary thing you should have, and then you build up the rest. Well, thank you very much, Niels. Again, it's been very educational, and yeah, see you next time.